to everybody. I am Luca Silvestri from University of Rome Niccolò Cusano, and I am co-chair together with Professor Antonio Forcina from University of Naples, Partenope. And welcome to this room that is entitled Industry 4.0 Innovations and Interdisciplinary Contaminations between Management, Quality and Engineering. We will have 5 presentations. The first is named Life Cycle Phases and Design Morphology for the Implementation of a Cooperative Inventory Pooling System. All the authors from Germany, welcome. The second is Industry 4.0 Tools in Lean Production, Systematic Literature Review from Italy, and Business Process Centric Optimization Modeling from the South of Africa, and DaQL 2.0 Measure Data Quality Based on Entity Models. And the last paper will be, the last presentation will be Statistical Process Control of Assembly Lines in a Manufacturing Plant, Process Capability Assessment. I would like to present you the first presenter, Tommaso Gallo, from
Good evening.
Good evening, from University of Viterbo, Tuscia. Please, you can start with your presentation.
Okay. Can you see it?
Yes, perfectly.
Okay. Good evening, everybody. The article I would like to show you is entitled Industry 4.0 Tools, Production, Systematic Literature Review. This paper has been written by me, Tommaso Gallo, Chiara Cagnetti, Cecilia Silvestri, and Alessandro Ruggeri, and everybody is from the Department of Economy, Engineering, Society and Management of the University of Tuscia in Viterbo. So, first of all, let's see the summary. I talk about a brief introduction regarding the fourth industry, why it's becoming really important for the companies in the last years. What are the benefits deriving from and the advantages deriving from the use of Industry 4.0 technologies? We will see that companies will be able to get higher results and performances than their competitors with the Industry 4.0 technologies. I talk about the tools of Industry 4.0 with the aim to know what of them could be useful for the companies to increase their productivity, efficiency, and flexibility, and what of them could be integrated with the lean production. For this reason, I talk about the relationship between Industry 4.0 tools and lean production, and we will see that this particular relationship is not easy, and we will see it after. I talk about the collection of materials. I'll show you the methods we decided to use to make the article. And finally, I'll show you the results and the aims we wanted to achieve with the project. And we've got discussions and conclusions. So first of all, we know that the fourth industrial revolution was introduced for the first time in Germany in 2011, has becoming really important for the companies. Due to the high competition we have got today, lots of companies have to be ready to face the challenges of the dynamic global markets. And the approach to the Industry 4.0 technologies allows companies to achieve sustainable aims, having a good job environment inside themselves, improving moral employees, and reducing production time. And companies will be able to make products with a high quality level in such a way to satisfy needs and requirements of the customers. And we know that it's really important even to investigate about the integration between Industry 4.0 tools and lean production. That could be really useful for the companies, for them to get higher results and performances than the competitors. These were the aims we wanted to achieve. First of all, what Industry 4.0 tools could be implemented with the lean production, and what of them could be integrated inside the companies, could be useful for them to achieve productivity, flexibility, and efficiency. And these are the Industry 4.0 tools, starting from IoT, Internet of Things. which is considered as a key technology of the fourth industrial revolution, because it allows to have a real-time analysis of the entire supply chain. We've got also big data. It's really important because big data gives us the possibility to put in relation big quantity of heterogeneous data. And also cloud computing is identified as the provision of services from a supplier to the end customer through use of internet network. We have also to talk about cyber-physical systems. Cyber-physical systems are really important for the companies because to use them is necessary a high level of preparation by the staff, so by the person who will use the CPS. And CPS allow to acquire and control useful information. We have got also robots. Robots can replace human work, can acquire and exchange data, and obviously can help the operators inside the companies in their task. We have got also technology. It's useful to analyze the contribution of technologies in a company. And finally, process is useful to study the security of the various business processes. So we know that the integration between Industry 4.2 tools and lean production could be useful for the companies. This particular integration could be called as a lean automation. And several authors think that this integration will allow companies to get higher results and performances than their competitors, to accelerate the development of lean systems in manufacturing companies, and to reduce the perceived risk deriving from the high implementation costs of Industry 4.2 tools. But there's a problem because a literature missing the studies that develop this topic from a literature review point of view. It means that we haven't enough studies to show, to explain how is possible this particular integration. Although there are lots of authors who think that this integration could be useful and possible for the companies. And about the collection of materials, I show you the methods we decided to use to make the paper. All the articles have been collected from two databases, Scopus and Web of Science. Both are reliable, and we decided to collect all the English articles because English-British language is considered as an international language. In Scopus, for instance, the search criterion was title, abstract, and keyword of the author. And these are the keywords we decided to use in both databases. So Industry 4.2, lean production, and Industry 4.2 tools. And at the beginning, in Scopus, we had 52 papers, but only 16 were consistent, coherent with our research. In Web of Science, we had 47 papers at the beginning, but only 15 were consistent and coherent with our research. So at the end of the day, we decided to cancel 6 duplicates, and so we had 25 papers. And we have already reported in the conclusions that 25 papers is a too small number to read. This is the reason why, for the next time, the next step will be to consider more articles to improve, to increase our research. And about the results, from this table, it's possible to see that the 32% of the articles has been used a case study as research methodology. So he needs articles on 25, it has been used a case study, in 6 of them a survey. From this table, it's possible to see that the 28% of the articles has been collected from International Journal of Production Research. So 7 articles on 25 are from this particular journal. And the 44% of the articles has been written by 3 authors. 6 of them are from Brazil, 5 from Italy. And if you consider the continent of the first author, it's possible to see that 14 articles on 25 are from Europe, 6 from South America, only 4 and only 1 from Asia and Africa. This is the reason why for the next time it will be necessary to collect articles not only from these places, but also from Northern America and Oceania, because we haven't any articles from these 2 places. And in this table, we decided to report all the authors of our references. We'll talk about Industry 4.2 tools integrated with lean production. Obviously, not all the articles of the references have been reported in this table because not all of them talked about Industry 4.2 tools integrated with lean production. But it's possible to see that there are several authors who think that this integration could be useful for the companies and is available, is possible. And if we see the Industry 4.2 tools part, it's possible to say that the most used are IoT, big data, cloud computing, CPS, robotic technology and process. But as we have already said, we haven't enough studies to explain to show how it's possible the integration between Industry 4.2 tools and lean production. And about the discussions, we know that several authors think Industry 4.2 tools should be integrated with lean production, as reported in the previous table. But several authors think that there's another important factor we have to consider. We mustn't forget it. This factor is the human factor, the man, the employee, the internal customer. And it's really important for the companies because we have already said that to use the separate physical systems is necessary a high level of preparation by the staff, so by the members, the persons who will use the CPS. And other authors think that the human factor will still have a decisive role inside the companies, notwithstanding in the future we will have lots of machines. And other studies highlight that a company can't get good results if the employee, the internal customer, doesn't work in a good job environment, or if he hears on the grapevine that this job could be threatened by the innovation technology. So this is the reason why the fourth industrial revolution shouldn't be considered as a synonymous of elimination of the human work, but it should be considered as an opportunity for the man, for the employees, to find new forms of job, to find new forms of work. And other authors think that the most important Industry 4.2 tools for the companies are IoT and big data. These are called as the basic tools of the fourth industrial revolution, without which a company couldn't even start its process of the fourth industrial revolution. And finally, about conclusions, we have already said only 25 verticals have been analyzed. A too small number to reach exact conclusions, so the next step will be to consider more articles to improve the research. And we used only 3 keywords: Industry 4.2, lean production, and Industry 4.2 tools. So next step will be to consider more keywords for our research. And we have to consider here articles from Northern America and Oceania, because we haven't any articles from these 2 places. And finally, lots of authors think that the human factor could be useful and could be really important for the companies to integrate Industry 4.2 tools with the lean production, because the innovation technology is not from the machines, is not from the robots, but innovation technology is from the man. And the man is a source of a guaranteed success now and in the future. Thanks for the attention.
Thank you, Tommaso. Any questions? Okay, I have a question. I'm interested to know which are the main instruments of the main Industry 4.0 tools for make more efficient the lean production.
Okay, so in my opinion, I think that according to several authors, the most used Industry 4.2 tools that could be useful for the companies to accelerate the process for the integration between Industry 4.2 tools and lean production. The tools could be big data. These are the most used and the most reported by lots of authors. In that table, not all the authors who talked about Industry 4.2 tools and lean production have been reported, because I hadn't enough space inside the slide of PowerPoint to insert all the authors. But there are lots of authors who think that IoT and big data will be really important for the companies and will still have a decisive role now and in the future inside the company. So I think that all the Industry 4.2 tools will be useful, will give a help to the companies integrate the process of the fourth industrial revolution. But in my opinion, and in the opinion of lots of authors, IoT and big data are the most important.
Okay. Thank you, Tommaso.
Thank you.
There are not additional questions for you. I can present Mageshnee Munsamy from University of South of Africa. Munsamy, you can share your screen and you can start.
Good afternoon, everyone.
Good afternoon.
I'm Mageshnee Munsamy, and this work was done in conjunction with Professor Anesh Tulukdari from the University of Johannesburg. And our research work is based on using business processes for optimizing operations. So, as we know, coal is a significant fuel source of power generation. It's accountable for 36% of global production, and it is a primary source of power generation in South Africa. 60% of global power, 60% of coal-fired power stations are less than 20 years old. So that means they still have a significant lifespan, and an additional 170 gigawatts of coal-fired power is under construction. Existing power plants are accountable for 30% of the CO2 emissions globally. So improving the efficiency of coal-fired power stations is a priority. 4IR technologies have been identified as an opportunity for optimization of power plants, and digitalization is noted has potential savings of $80 billion annually. However, digitalization comes with increased energy usage, which should typically be offset by improvements in energy efficiency of the digital technologies. Therefore, it still makes energy efficiency improvements critical. Energy models have typically been used for analyzing and improving performance of energy systems. These energy models analyze at various resolutions. So we're talking at global systems, regional, country, local, business process and equipment. And some common models are the TIMES model, the POLS, the Markle, the E3ME models. And these are typically at the global, regional, and country and local levels. These models look at the energy system from fuel extraction to final energy users, and are either classified as bottom-up, top-down, or hybrid models. Common characteristics of these models are that they are complex, they're time and data intensive, and require a high level of expertise. At the process and equipment level, there's typically proprietary software like the Aspen Energy Analyzer, the ARENA, the Envisage, and Sentient Systems. These models are highly specific to process operations, and they're data intensive. So they typically require large volume of disaggregated data. However, if we look at it, there's a notable gap at the business level. Where is the whole business considered from all operations, from HR, finance, inclusive of process operations? So we took business processes, which is a recognized business management tool, and proposed it in developing a comprehensive energy model for a business. And in this case, the business we're talking about is a power utility, and we include optimization functionality. So we did is a literature study. We used Scopus, and our search terms were coal-fired power generation, modeling, and fourth industrial revolutions, to see the publications and the research done in this area. We constrained it to the last 10 years, 2010 to 2019, and with these terms, we only identified 152 publications. There was a year-on-year increase in publications, but there were exceptions where in 2012, 2015, and 2017, there were decreases to the previous years. Then we looked at a country profile. So we see China has the highest number of publications at 66, with the USA at 31. The United Kingdom has 11 publications in third place. So you can see there's significant gaps between China, the USA, and the UK. China and the USA are the top coal-fired power generating countries, and India in third place. But if we looked at the number of publications, India only has had 5 publications in the last 10 years. When we analyzed the top cited papers and the most recent papers to look at common themes that emerged, we found carbon dioxide emission control was a theme, and modeling and simulation for optimization, whether it's energy optimization or simple process optimization. Okay. So in developing this business model, we chose business processes, right? As we said, business processes is an established management tool, and it is applied in sustaining consistency, quality, and transparency of operations. Business processes detail the logical sequence of activities in execution of a business activity. So it's very methodical, logical, and in most cases sequential. Business processes can be quite intensive, so they are typically hierarchically structured. And so we developed a hierarchical structure for a power utility. So we developed a 5-level hierarchy. So level 0, we said, is the functional categorization of the power utility. So here we're talking about, is it the generation part of the business? Is it the transmission part of the business? Then level 1 is a specific area within each business unit level. So if we take generation, a business unit within generation would be the boilers. Then a categorization within each process. Level 2 is a categorization within each process area. So if we continue with boiler, process area could be boiler operation, boiler maintenance. Then level 3 is the business process itself, which tells you the activity to be done. So an example would be the startup of the boiler. And level 4 is a specific step of the business process. So it could be saying, ensure that all inspection openings are properly gasketed and closed. And then level 5 is a specific task within the business process step. So in ensuring all the inspection openings are properly gasketed, the specific instruction would be to go and physically check each opening, is it gasket, and mark off on a check sheet. So that's the hierarchy we use. Using that hierarchy, we developed a business energy demand. So it's a summation of various levels. So K represents the business sites, L represents the business process, M represents the business process step, and N represents the resource. So it's a bottom-up approach. So we're starting from the resource required for each business process step, accumulating or to the number of business processes for each site and to the number of sites. So it's resource energy demand times utilization time. To execute equation 1, an energy model was developed. And looking at equation 1, we identified 3 requirements: the business processes, the resource required for execution, and optimization options and technologies. To enable each of these executable per equation 1, we developed databases. So the business process database comprised of the business process applicable to the power utility and is structured as per the business process hierarchy described in the last slide. The resources database is structured on functionality such as ICT, which is both your office and network infrastructure, your building facilities, here we're talking HVAC and lighting requirements, your operations, so it's your pumps, your fans, the boilers, the turbines. Then within each functional area, the equipment are further classified on equipment design. So pumps are further categorized as centrifugal or positive displacement pumps. Boilers are subcritical or supercritical. The optimization database comprise the optimized business processes, when we redesign the business processes to include 4IR technologies such as IoT or big data, and the resources required for execution of the optimized processes. Now, in operation of a business, you get uncertainty. A business can operate within a range, and it can operate day 1 on the lower end of the range, and if there's a problem on day 2 at the higher end of the range. So to include this uncertainty, we use the random function constrained to the upper and lower limits. This introduces noise into the model, and to moderate this noise, we used the Monte Carlo simulation. So we ran the Monte Carlo simulation until the change in standard error of the mean of the energy demand was negligible. And at that point, we used those conditions to identify our baseline operation for the power utility. This is just an illustration of the methodology. So you select your business process from the business process database. You select the resources required to execute each step of the business process. You simulate the energy demand. You select the optimization options that could be used for that business process. And in some cases, if there's multiple options, you evaluate the options via design of experiment, which evaluates options singularly or in combination. And then you get the new energy demand based on the optimized process. So the results, we looked at a power utility with the energy demand of a generation site and a central corporate office inclusive of building facilities. The corporate office operations include establishment of power utility vision and strategy, the sales and marketing, integrated planning, customer service management, ICT, financial management, HR, and research and development. The generation site operations included the electricity generations, which we're just going to call operations going forward, planning, maintenance, logistics, ICT, financial management, HR, and SHEC. So the generation site we looked at generates 3,600 megawatts of electricity via 600 megawatt coal-fired boilers with a coal feed rate of 1,800 tons per hour. For the operations process, we only evaluated the steam generation process from coal delivery to steam turbine. So for evaluating the site energy demand, we characterized it as business activities, facilities demand, and network demand. The generation site had additional demands of coal and other fuels. So this is the sample of a business process, and that is simulated to identify the site energy demand. So if we look at the results for the generation site, if we look at figure A, it's an overall site energy demand where you can see the P represents the primary axis and the business activities represent the secondary axis. And you can see that the business activities demand is the highest energy demand. And this is because we included the operation. So we included the steam generation process in your business activities. And then your facilities and network are the second two. Because we used a bottom-up approach, we could present our results at various resolutions. So in the first figure A, it was at a site level. And if you look at figure B, it's at a business unit level. So we can see, we look at the various functions, HR, ICT, maintenance. And in our case here, we see, again, P represents the primary axis and S represents the secondary axis. And we can see that the SHEC activities, the financial management activities, and the logistic activities have the highest energy demand. And what is characterized of these business unit activities is they have voluminous, repetitive tasks. So we're talking about constant coal quality sampling, payment of invoices, the receival and the delivery of material. And then the last resolution we could look at is the equipment energy demand. So we just looked at the high energy consuming equipment, and you can see it's all the equipment related to the production of steam. So it's your primary air fan and your boiler feed water pumps that are your primary equipment contributing to energy demand, as is expected, because your primary air fan feeds your combustion air for the coal combustion, and your boiler feed water pump is your feed for your steam. If we look at the corporate site, we can see figure D shows the site level energy demand, and here business activities is the highest energy, facilities is the highest energy demand, followed by network and then business activities. If we're looking at the business unit energy demand, we can see the customer service management, vision and strategy, and sales and marketing are the highest business unit energy demands. The next thing we looked at is optimization. As the generation site is accountable for the majority of the energy, we looked at optimization of the generation site. So we looked at Industry 4.0 and cleaner production technologies for optimization, as their value add in energy management is acknowledged. Because the process equipment of your fans and pumps are the largest contributors to the energy demand, we looked at the impact of variable frequency drives. And for Industry 4.0 technologies, we looked at Internet of Things, big data analytics, mobility, and automation. In simulating the results, we combine mobility and IoT because IoT enables mobility. So we had in total 4 optimization options: VFD, automation, IoT, and BDA. Then we used design of experiments to develop a simulation protocol for the options. So we could see which option singularly or in combination gives us the best results. The coal energy demand is excluded from the analysis, and the focus was on the electricity demand. So if we look at the optimization results, if we look at figure F, we can see that the application of VFD had the highest singular impact, approximately 22% reduction in energy demand, followed by IoT. So, and the combination of VFD, automation, IoT, and BDA gives the best of 28%. Then we looked at the VFD on the actual equipment, and we can see VFD has the biggest impact on the primary air fan and the boiler feed water pump. So, and these are the equipment with the highest energy demand and potentially has the variation in flow rates and usage. Because we're using business processes, we could look at further factors. We could look at also CO2 emissions, specifically the electrical CO2 emissions. And again, we can see VFDs has the highest impact. And of course, the combination of all the options would give you the best reduction in CO2 emissions. But we could also look at personnel hours because we use business processes. And we can see here in personnel hours, IoT has reduces personnel hours by approximately 4.5%, automation about 3%. So that's the additional information that we could get using business processes. In conclusion, coal-fired power plants are still an integral part of the global power supply market. Thus, the energy management is a priority. A business process energy model is proposed for evaluating and optimizing the energy demand of power utilities. The business processes for the power utility was mapped, models, and variables adjusted to predict the baseline energy demand. Industry 4.0 and cleaner production technologies were adopted in optimizing the utility's energy demand. The model provides the utility with critical information specific to its equipment and operational regime. So that's important to know to aid in the energy optimization intervals. Specific to this simulation and this application, the results demonstrate that application of VSD has the highest impact on reduction of energy demand and is potentially the best investment, followed by IoT. The application of IoT especially would be a key step towards digitalization of operations. Just a summary of our references. Thank you, and this question.
Thank you, Mageshnee. Any questions from audience? I want to ask you something. I'm interested to know if you already considered a further step for applying this model to an enterprise, to a company, and if yes, the sector of the company that you selected.
Yes, we applying it to a water distribution utility, and we applying it as well to a logistics enterprise. So we're looking at enterprises that have multiple sites, and yeah, so we have applied it to other different industries or areas.
Okay, thank you, Mageshnee. There aren't other questions, so we can. I can introduce Christian Lettner. Christian, you can share your screen. From Austria.
Hello, from my side. One moment, please. Okay, hello everybody. My name is Christian Lettner. I'm from the Software Competence Center Hagenberg, and today I want to introduce you our work DaQL 2.0, measure data quality based on entity models. This work has been performed in cooperation with Reinhard Stundner from FAW, Werner Fragner and Franz Rauchensauner from the Steve Automation Group, and also from Lisa Erling, which she is also from the SSCH and also from the Johannes Kepler University in Linz. DaQL stands for Data Quality Library. There is also the German word DaQL, which means Dachshund. These are small dogs that are used to hunt small foxes, and yeah, we use this analogy to develop DaQL to chase data errors and data glitches. As you all know, bad data quality leads to a lot of costs in the daily business, and nowadays also in machine learning. If you have bad data that goes into the training of the models, also your models will not perform that well as expected. So data quality is a very important topic nowadays, and this is the reason why we invested here in such a framework which tries to improve your data quality. Originally, this work has been performed in cooperation with Siemens Energy, and it's basically a framework or a domain-specific language to define data quality rules over relational data. The original version there was heavily based on SQL, and it also made use of the Pandas framework in Python. And yeah, it was that this final solution was published at the DEXA conference last year. This year we started with a complete redesign in cooperation with the Steve Automation Group, and the main contribution of this redesign was that we now do not perform the checks on tables or SQL based, but we do the data quality checks based on so-called entity models you can define. So it's also technologically, it's heavily based on SQL alchemy, and yeah, we started on this work this year, so it's currently also a work in progress, and the development will continue in the next month on this work. So what is an entity model in our context? So basically we consider it as the business object you want to test if it's fit for use in your certain context. So to say, if the data quality rules you define conform to the if that your data conforms to the data quality you define. For example, a person, as such, the data must not reside in one table. It can span over multiple tables. For example, a person that consists of addresses, and the person together with the addresses is the business object or the entity you want to check for its fitness to use. As such, the entities also overlap depending on the domain or the rule you want to test. Here a simple toy example from the industry to explain it a little bit more into the detail. You can see here machines who produce products, and every machine has measurement devices installed on it which continuously measures values, and also the final produced product also has properties which are stored here in the product measurement table. So, and now you can think of a process engineer who is basically interested in that his machines are up and running, so his and he wants to check whether the quality, the data that is produced by these machines is good. So he's mainly interested, for example, in this section of the data model. On the other hand, product quality control, whose main focus is on the product side, defines its rules. So on the right hand part, so the product as the entity with all its measurements below here. So, and how can you do this using the DaQL language? Basically, you have to do 3 steps. First, as I already mentioned, it relies on the object relational mapper SQL alchemy. So first, you will have to define the mapping from the relational database to the object model of the OER mapper. This has to be done only once and can be reused afterwards for all data quality rules. So in the second step, you have to define your entity model. So it's basically based on the mapping you defined in the first step, which also contains all the tables that are needed for the entity, as well as the join buffs, how the tables relate to each other. Second is that you also have to define the granularity of your entity model, which says what is the level at which you want to test your data. And third possibility also introduced recently was that you can also define a timeline of your entity. So if you have different versions of your entity, you can define this line by specifying an order by criteria. So having done this definition of the entity model, you can apply data quality rules on this entity model in the third step by applying a sequence of constraints on this model. If you also have made use of the timelining thing, you also have to specify when you write the concrete data quality rule, which version of the entity you want to test. So you have to specify this with one of these 2 methods, the current, which means the most actual entity will be used for testing, or if you need some previous entity for your tests, you have to specify this with the previous method here. Another thing, part of the language, is that you can specify the mode of execution, which means that if you define your constraint pipeline, you finally can can analyze these pipelines using the success method, which means that you get all the entities that passes this test, or if you're interested on the opposite, you can specify the failure mode, which then will give you all the entities that fail the corresponding test. Yeah, all these things is lazy evaluated, so triggering an execution must be done by applying one of these 3 actions. Collect gives you all the entities, count does a simple count of the respective numbers or number of entities, and with the store method you can store your results in a database to track the data quality over time, so that you can have a look on it, how, for example, implemented data quality measures, how if these have a positive effect over the time on your data quality. Coming back to our example, for example, with the process engineering domain, as said, maybe he focused on this process measurement table. Here you can see a small example, as I said, just a toy examples. You can see here different values measured over time, and one assumption of the process engineer may be that the measurements taken over time must slightly vary. Otherwise, if always the same value is stored in the database, this seems to be an indication that the sensor does not work correctly or something other goes wrong. So this rule can be easily specified using DaQL. doing so, you first, as said, you have to specify the mapping of this data model to the object relational, to the object model. Here, this is done basically based on the SQL alchemy notation. You can see here all the columns that are should be available from the database, as well as a definition for the relationship to other tables here, the relationship, the foreign key to the machine table. After you have done this, you go to the second step where you define the DaQL entity model, as done here in this example. Here is the respective statement. You define here, this is the model 1 is the reference to the previously defined SQL alchemy mapping, and in addition you have to specify here what is your entity key, what is your granularity you want to perform your data quality test. In this case, we want to test whether the temperature sensor or the sensor for getting the weight works correctly. So this is the granularity we want to do our test. So as you have to specify this by giving here the respective key, so process management.metric, which uniquely identifies the sensor, and also because I'm interested in the history of the values, I have to specify the ordering of the values as they arrive in the database, and this ordering is given by the measure date in this table. Having done this definition of the entity model, I can apply arbitrary rules on this model. In our case, I just have this one rule and specify it by the apply constraint statement, and give them the rule in the form of a so-called lambda expression, as you can see it here, where I say X is the current entity which should be tested, and with current I specify that I like to test the current value of my sensor, and this value should be different than the previous one, which means the value which was right before the current one should be different than the previous value. And if this test is okay, then this entity is resolved to as successful. If the values would be equal, the entity would be delivered as a failure entity. So the respective data quality engineer would have an indication that something goes wrong in this setting. Another example which shows a little bit how the navigation through a data model is performed is given here. The question is, are the product measurements calculated correctly? So I have products, and here the product measurements, and the example here is that I have a product measurement for the weight of the overall product, and this weight must be equal to the sum of the weights of the parts that were assembled for this product, and all these assembled parts, the weights of these assembled parts are stored in this process measurements table here. Yeah, the same steps as before. You have to define your entity model. The granularity I want to test is the level of product, so I want to have a result per product, so I specify product.id is my granularity level. I do not have a timeline here because products in our setting here do not have history. There's just this one product that exists in the domain. And having defined the entity model, I specify here my my rule defined as a method which checks whether the weight which is stored on the product measurement actually is really the sum of the weights stored in the process measurement. Doing so, I go to from the product, the current version of the product, it's just the one that's available here, go to the machine, and from the machine to the measurements, and I take there all the metrics for weight and sum them up to an aggregated value. And on the second step, I go from the product down to product measurements, take the metric which represents the summed, the aggregated weight, and if this value that is stored in the product measurement equals the value that is calculated before, then true is returned, meaning for this entity the data quality check has been passed and successfully resolved. Yeah, this was the way how you can specify such data quality rules. You also need an environment where you can execute these rules, and there we currently tested the framework in two different environments. The first one is in an interactive way using Jupyter notebooks, where you can basically start all your tests manually, and as a result you get whether the test was successful or failed for a certain entity key. Here this is, for example, a global unique identifier that uniquely identifies my entity in this setting here. In this setting all the entities failed the respective test. This is more the batch version of executing the data quality rules. We also wanted to provide a solution to execute this in a streamlined fashion. As data arrives in the database, it should be immediately checked whether the database is okay and fit for use. So we also made a wrapper that it can be used in Apache NiFi, where data arrives at sources, it will be tested in a separate processor, and then the result is sent back to either to a database to track the development of your data quality, or back to other subsequent processes that may have to know how the quality of your arriving data is right now. Yeah, this was the status of the work currently. As said, this is an ongoing research project. Actually, we are working on the topic that we want to include some kind of data quality rule lifecycle management, which means that in practice also your rules may evolve over time as new versions of software or sensors will get deployed on your manufacturing plant, and so you also have to provide some ability to continuously update and manage your rules, as well having a way to track the lineage of your rules, so to say, that if you get a result that your data entity failed some certain tests, you also want to know which exact test was this, and here you need some administrative features to get this done. And the other future topic would be more on the core of this framework. Currently you have to define one single entity model, and then you can specify arbitrary rules on this entity model. The goal is that in future you also want to be able to define rules based on different sources or entity models, so that you easily also can specify things like duplicate detection, or just if you have two different data sources, test whether the two data sources are in sync or for any reasons are out of sync, which also might be an indication that there are problems with your data quality. Yeah, that's it from my side. Yeah, if there are any questions, feel free to ask.
Yes. Thank you, Lettner. Yes, I have a question from Professor Antonio Forcina.
So, thank you, Christian, for your can you hear me?
Yes, I can hear you.
Okay. Thank you for your really interesting pitch. And I was thinking when I were hearing your presentation, what about resources? I mean, what about resources in terms of costs and operator skills to implement this model? And depending on the resources you need, which kind or which size of company do you think your model is suitable for?
Thanks for this interesting question. The primary intention was that we create a framework that is not only usable by IT personnel, so programming staff, but as you can see, as it is right now, you also have to specify Lambda expressions, Pythons, and so on. So this right now it's not feasible for them. So you still have to write the rules in some skilled IT personnel, but nevertheless it provides some sort of abstractions for them, which also makes the life for them much easier, as we have seen in our current project. But the original goal was that we target another group, but this, as far as it now is in the state, it's it's not so far.
Okay, thank you so much.
Okay, Ragol Sebastian.
Hi there, interesting talk. Is execution speed, performance an issue at all? Because I imagine if you have enough data and arbitrary complex rules, then you run into timing issues. Have you thought about this, or do you plan to speed it up at any point, or is this not a concern at all?
It's a big concern. The original version, there we also tried to do an execution engine based on Spark. This we dropped in the current version. Currently, we do all the processing in memory, in the object model loaded through SQL Alchemy. This actually restricts you to the memory you have available. But we took this, we went this way because we wanted to have a highly expressive language. We also did our first steps were that we tried to compile do the complete execution directly by generating SQL queries, but this restricted the way you could write rules very much. So we decided to go this way, do the execution on the object model, but with the drawback that you are restricted on the memory. And
very interesting. Thank you.
Okay, thank you, Christian Lettner, again. And now the last presentation of the day. Good evening, Letizia.
Hi, good evening. Hi.
Okay, you can share your screen. And
yeah, I'm sharing it, and tell me if you can see the presentation.
Yes, perfectly.
Okay, can you see it and can you hear me?
Yes, perfectly.
Okay, we can start. So, good evening, everyone. I'm Letizia Tebaldi, a second-year PhD student in Industrial Engineering at the Department of Engineering and Architecture of the University of Parma. And during this brief presentation, I will illustrate results from a statistical process control that we have carried out on two different activities which are performed on a filler machine. The general context is clearly that of quality management, which is considered a real strategy adopted by companies for gaining competitive advantages. And as you can read from this, quality refers to one or more desirable characteristics that a product, a service, or a process should possess in order to satisfy customers' requirements. And from this definition, it clearly emerges that within the industrial context, it is also essential quality control at the process level in order to ensure compliances of the final items. Among the main tools for quality control, it is worth mentioning the statistical process control, which allows to monitor and control quality through the measurement of statistical production metrics, or also the famous Six Sigma method, which is a procedure whose aim is to reach the target of operating with 3.4 defects per million opportunities, meaning a process yield which is equal to almost 100%. And there are also their tools. Clearly, I have just mentioned these two since they are involved in this study. After this really brief introduction, I can, let's say, define the work. As I have already said, the aim of this work is to implement process control for a filler machine, which is produced by a company based in the north of Italy and producing food machinery, in order to control and monitor quality for the overall improvement of production efficiency. So how we carried out this work? First of all the activities were identified in order to select critical to quality, that is to say, critical activities which need to be monitored and controlled. In this case, two activities were chosen and selected as pilot case studies. As a third step, the instruments used for measurements were validated thanks to the ANOVA gauge R&R procedure. And after this validation, the statistical process control was implemented through two capability indexes. Finally, for the second case study, a software for improving and optimizing the process was also developed. The ANOVA gauge R&R that I have just mentioned is a tool for validating instruments, which considers repeatability and reproducibility of the measurement. And in general, if the value obtained is below 30%, the instrument is reliable, otherwise clearly not. And in this study, we use Minitab software for computing this value. Instead, the two indexes computed for the statistical process control are two process capability indexes for assessing the performances of the processes related to the production specifications, and they are CP and CPK. In this slide, you can see the formula and the definitions, but I won't stop and detail them because I think that these indexes are quite common and all of you for sure know their specifications. The value of CPK index is then related with the sigma levels, and specifically for case study 1, the target set from the company is a level of 4 sigma, to which corresponds CPK equal to at least 1.33, while for case study 2, the target is set at sigma level of 6, to which it corresponds a CPK of at least 2. So this was the methodology, and now we can go to the detail of the two case studies. So case study 1 refers to the measurement of the backlash between the slewing ring and the pinion of this filler machine. It verifies the correct backlash between the teeth of the pinion and the teeth of the slewing ring. As you can read in the slide, a certain backlash between the teeth is important in order to avoid friction and overheating problems or unexpected forces. Instead, case study 2 refers to the measurement of the height of the clamps of the rotatory filling machine, because it is necessary that they are positioned so that the bottle transfer can be carried out in a correct way. For case study 1, here you can see the procedure for recording the backlash, and it is manually measured by means of a thickness gauge, which has a resolution of 0.05 millimeters. And after the first measurement, the pinion must be rotated 360 degrees so that the backlash between the same tooth of the pinion is checked again and measured with respect to different tooth of the slewing ring. A total of 30 measures was recorded by 2 operators who repeated the procedure for 3 times. So each time they got 5 measures. But in this first case, this measurement system was not acceptable since the ANOVA gauge R&R returned a value equal to 71.77%. And according to that, the operation of measurement of the backlash made by the 2 operators was standardized, and operators were trained thanks to some images that were shown to them. And again, 30 measures were collected, but also in this case, the result of the ANOVA gauge R&R was greater than 30%, and specifically, as you can see, 46.58, and an alignment jig that you can see in the picture on the right in red was introduced in order to increase the accuracy of the centering operation of the 2 teeth. Again, 30 measures were recorded, and this time the measurement system can be considered acceptable and reliable since the analysis got 15.56. With the 30 data collected, we were able to build the control chart, which is shown in this slide. And in this case, CP is equal to 1.51, while CPK is equal to 1.45. So both values, which corresponds to a sigma level of 4.3, which is actually in line with the target set from the company and even better. And it follows that the first process is under statistical control. For case study 2, instead, the measure of the height of each individual clamp is measured with respect to a reference point, and this operation is performed by means of a laser scanner. And the difference between the highest and the lowest weight height value must be less than 0.2 millimeters. Otherwise, it is necessary to adjust the clamps for which the difference is higher. Again, in this case, 30 measures were recorded, and this time we were, let's say, lucky because the ANOVA gauge R&R got 27%, which is actually lower than 30. So the measurement system was acceptable without any adjustments. This result in part does not surprise because in this case we deal with a laser measurement, which is probably more reliable than a manual operation, which can depend on different factors. But conversely, this time the problem was related to the capability process indexes and more specifically with CPK. In fact, from the control chart that you can see, it is immediately noted that the process is not centered, and CP is equal to 1.45, and it is fine, while CPK is definitely too low, and it corresponds to a sigma level of 0.9, which is very far from the target, which was set at 6 in this second case. And in order to solve this problem, the clamps adjustment process was modified. And to this end, the difference in height between the highest and the lowest clamp was reduced from 0.2 to 0.1 millimeters. And it was then decided to use washers with a thickness of 0.1 millimeters instead of 0.2 millimeters as previously used. In order to get finer height adjustments of the clamps. New values obtained are definitely satisfactory, as in this case CP is equal to 4.23 and CPK is 4, which corresponds to a level of sigma equal to 6, which was the target set from the company. But despite the indexes increased, also the height adjustment of the clamps time increased because it took 1 hour and 15 minutes compared to the previous 45 minutes. Despite now it is more accurate and finer. So in order to speed the process, a software tool was developed under Microsoft Excel, thanks to some macros which were developed in Visual Basic for application language. And the operator enters in this tool the single heights measured, and the tool is able to provide the best solution, which allows to modify the lowest number of clamps. And it exactly says how many washers to add in each clamp. And thanks to this software, the operators are able to save 73% of time because this procedure takes around 20 minutes. And here you can see a screen of the software interface that was of the software developed. And this final slide summarizes the results. So as I've already said, for case study 1, the measurement systems at first was not reliable at all, and 2 different corrections were required. Anyway, the capability indexes were both satisfactory at the beginning, and the process was under statistical control. Instead, this not happened for case study 2. Well, at first, the measurement system was fine in case study 2, but the CPK index instead was not acceptable. And according to that, the process of the height adjustment was modified in order to reach 6 sigma level. But this procedure took much more time, and for solving this problem, a tool was developed in order to help the operator in identifying the best level of height to which set the clamps. For the future, it is in plan to extend the statistical process control also in other processes and in other departments of the company, since this analysis was required directly from the management of the company in question, and also to automate the acquisition of data required for the analysis as well. So I finish with my presentation, and thank you for the attention.
Okay. Hi, Letizia. Thank you for your interesting presentation. And I ask to the audience if is there any question?
Yes, I have a question.
Yes.
Thank you for your presentation. I would like to know among the main advantages, for the implementation of this tool. Which is for you the most effective, the most important?
Well, the most important is that at first the selection of the best height to which set the clamps were the operator who had to choose the best height. Instead, in this way, the tool, once the operator insert the height that he has measured, it is the system and the tool that gives back the best value.
Okay, and in your opinion, which is the best starter condition for a proper implementation?
The best, sorry?
Starter condition, no?
What do you mean with starter condition?
No, about for the implementation of these tools.
Yes.
no, which is the proper environment for,
well, one of these, I to be honest, I don't understand what you mean. For instance, we are in a company, that produces food machinery, and in this case, we are talking about a filler machine, and so in other contexts similar to this one.
Okay. Okay. Thank you. Other questions?
I have just an additional curiosity. Why did you choose different sigma levels for the case studies?
This was required from the management because
okay.
Yes, as I said, this analysis was required from the company, and so after different meeting, they believe that these activities required is more critical for them, and so they wanted to reach a higher level of quality, let's say.
Okay, thank you.
You're welcome.
Okay, thank you. So we finished with the presentation. Thank you to everybody for attending this interesting track, Industry 4.0 innovation and interdisciplinary contaminations between management, quality, and engineering. I want to thank you, my co-chair, Antonio Forcina. And this is all, and bye.